Alright, now that my self-esteem is just obliterated because I insulted myself, let's talk about special trig limits. So if you look in here, let's look at the actual limits first. So if you look at this, it appears that there's some kind of mistake been made, because they're saying that the limit as x approaches 0 equals 1, but yet there's an x in the denominator. So how did they come up with that? Well, I'll tell you tomorrow. Okay, we're going to talk about the proofs of these two special limits tomorrow. But for right now, what I want to focus on is that these are to be accepted as fact. So if you have the limit of sine x over x, that is equal to 1. And if you have the limit of 1 over cosine x over x, that equals 0 all the time. And believe it or not, those two things are going to help us to simplify quite a bit. For example, over here, if we tried to evaluate this limit by direct substitution, we would again have a 0 in the denominator, which is bad. So instead, we're going to try to manipulate this argument, this tangent x over x, to have one of these in it. And you'll see why that's useful in just a moment. So, how can we turn tangent into a sine or a 1 minus cosine? Well, the 1 minus cosine is a little far-fetched, but we do know that tangent is equal to sine over cosine. So I'm going to rewrite this as the limit, as x approaches 0, of sine x over cosine x divided by x. And we know that complex fractions are bad, so we're going to go ahead and do stay switch switch. And that is equal to the limit, as x approaches 0, of sine x over cosine x times the reciprocal of the denominator is, here's my fingers, 1 over x. Okay, so we've still got an x in the denominator. But if we rearrange the order of this multiplication that is occurring, and we say the limit as x approaches 0 of 1 over cosine x times 1 over sine x over x. See how I just moved the sign over? Then that's our special limit. It equals 1. So guess what? We can plug in a 1 right there. And we get the limit as x approaches 0 of 1 over cosine x times 1. You know why we're allowed to do that? It's because of the properties we just learned yesterday. We learned that if you have multiple functions and you multiply, which one is it? If you multiply limits together, oh, right here, the third one. So if you have one thing times the limit, then you can just multiply them together. So we can say that, like pretend that our 1 over cosine is our f of x, and our sine x over cosine x is the g of x. We can just plug the k in there and multiply it. Alright, so where were we? Down here. So now we can plug in the 0, because cosine of 0 equals 1. So that means the limit is 1 over 1, which just equals 1. Yay, and we're done. So these are going to take a lot of practice, because obviously direct substitution was easy compared to this, but basically think of it as manipulating it so that the denominator will no longer equal 0.